China has once again shattered records with the construction of the Jinan Hangang Tunnel, the largest diameter tunnel in the country, completed in an astonishing 110 days. This engineering marvel lies 100 feet beneath the Yellow River and boasts a massive 56-foot diameter. It's not just the largest tunnel of its kind in China, but also the fastest large-scale project of its category globally. But how did China complete such a massive project in such a short amount of time? Let's find out. Before delving into the specifics, let's begin by clarifying the motivation behind this project. Jinan, the capital city of Shandong province, is split into two distinct areas by the formidable Yellow River. As a result of the division, there is an inherent logistical issue for the city's 9.4 million inhabitants, and that issue will only grow with the expected increase in the population size. To bridge this divide, China had two options. The first was to construct a bridge over the river. For most people, that would seem like the most logical answer to the issue, but the problem is that the Yellow River has an infamous issue. It's known for its devastating floods and infrastructure destruction. It's a river that has claimed countless lives over the centuries. Construct another bridge over the river, or build a tunnel beneath it. Due to that major issue, China chose to go forward with the next best solution, which was to build a tunnel underneath it. A tunnel presented a more secure option to protect both the city's infrastructure and its people, but it certainly wasn't the easier option. China Railway 14th Bureau Group Company Limited was tasked with taking on this monstrous project. Located 98 feet below the surface of the Yellow River in Jinan, the Jinan Hangang Tunnel is a dual-level structure that accommodates 6 lanes of traffic on each side, with a speed limit of 37 miles per hour. The tunnel is part of a larger 3.6-mile project designed to enhance regional connectivity. The secret to this record-breaking construction lies in the Shanhei Tunnel Boring Machine, a colossal piece of machinery that is 163 meters in length and weighing as much as 520 adult elephants or 5,200 tons. With a cut-ahead diameter of 57.4 feet, this tunnel boring machine was capable of excavating an impressive 50 to 59 feet of riverbed daily. That speed is a record for its size. To adapt to the clay, sand and silt geology and the 7.5 bar groundwater pressure under the Yellow River, a mixed-shield tunnel boring machine was selected. HeronConnect's mixed-shield technology is an advance on conventional slurry technology. The support pressure in the excavation chamber is managed using an automatically controlled air cushion. This means that heterogeneous geologies and high water pressures of more than 15 bar can be controlled even with very large excavation diameters. An individual, new slurry circuit was designed especially for this tunnel boring machine. The underwater segment of the tunnel, which traditionally would take years, was completed in just 110 days, thanks to this advanced technology. The effectiveness of the tunnel boring machine arises from its capability to dig while concurrently applying concrete to the tunnel walls, guaranteeing stability and conserving time. Tunnel boring machines are advanced machinery created for tunneling through different geological environments. They arrive with cutting-edge technology to improve effectiveness and security. The Shanhei Tunnel Boring Machine also features an innovative flushing system to prevent clogging and a conveyor belt to transport excavated materials efficiently. Interestingly, this extracted material is often repurposed, as seen in other projects like the Channel Tunnel between the UK and France, where millions of cubic meters of chalk marl were used to create a nature reserve. Additionally, the tunnel boring machine's telescopic camera allowed real-time monitoring of operations, reducing the need for external interventions. There are several types of tunnel boring machines, each suited for different geological conditions and project requirements. The Shanhei was a mixed-shield type that combines features of EPB and hard rock tunnel boring machines, so it was ideal for the mixed ground conditions it had to work in. The cost of tunnel boring machines can range from $5 million for smaller models to over $30 million for larger ones, reflecting their advanced capabilities. The most expensive tunnel boring machine cost $80 million, which would be an appropriate estimate of the Shanhei as well. The Shanhei Tunnel Boring Machine stands among the most efficient and cost-effective machines, considering the record time in which the tunnel was completed. The massive 6-story tunnel boring machine was eventually converted into a much smaller machine to complete the final stages of its tunnel project. The largest tunnel boring machine in the world, according to Guinness World Records, is the Mixshield S880 Qin Liangyu, built by German engineering firm Herrenknecht and operated by Bouygues Construction, which was used to excavate the Chek Lap Kok to Tuen Mun subsea road tunnel in Hong Kong, China. The Mixshield S880 weighs 4,850 tons, has an overall length of 120 meters and a shield diameter of 17.63 meters. The 17.63-meter tunnel segment was dug out between March 25 and November 3, 2015, after which the tunnel boring machine's shield was changed to a 14-meter one in order to finish the remaining tunnel with another Herrenknecht tunnel boring machine. The tunnels were finished on February 27, 2019, when the two 14-meter tunnel boring machines broke through. This machine, capable of operating at high pressure with robotic systems for maintenance, highlights the global competition in tunneling technology. In the second position, we find the Bertha tunnel boring machine, which has an impressive diameter of 57.4 feet, identical to that of the Shanhe tunnel boring machine, resulting in a tie for size between the two. Conceived and constructed in Osaka, Japan, Bertha was moved to Seattle to initiate digging for an underground double-decker roadway. This tunnel boring machine was named in honor of Bertha Knight Landers, the first female mayor of Seattle. When launched in 2013, Bertha gained the title of the largest tunnel boring machine globally. It reached an astonishing length of 91 meters and had a massive weight of 6,900 tons. Of course, this enormous machine earned the moniker Big Bertha. Its job was to build a 1.7-mile tunnel to take the place of the deteriorating Alaskan Way viaduct. Although large and powerful, Bertha's expedition was far from easy. While digging, it hit an unidentified object, probably a steel pipe, causing significant damage to its cutter head. To resolve the problem, the team needed to excavate a 60-foot deep access shaft to access the buried tunnel boring machine. The cutter head, with a massive weight of 2,000 tons, posed an additional challenge. It had to be raised to the surface for repairs. A uniquely engineered steel gantry, upheld by 48 hydraulic cylinders, was built to manage the lift. After the cutter head was successfully raised, it was shifted to a repair saddle for extensive maintenance. However, once repairs were complete, construction resumed, and by 2017, the tunnel was finished. The $80 million tunnel boring machine was subsequently disassembled. In third place is the Santa Lucia tunnel boring machine, the largest diameter tunnel boring machine in Europe, measuring 52 feet across. This machine was used to dig a 5-mile, 3-lane highway tunnel between Bologna and Florence. Construction of this tunnel began in mid-2017, and just 3 years later, the tunnel was opened for traffic. This critical infrastructure project addressed significant transportation challenges in the region. At number 4, we have Martina, the world's largest hard rock tunnel boring machine, boasting a 51-foot diameter. Developed by the German company Herrenknecht, the same firm behind the Shanhe, the Santa Lucia, and the Qin Liangyu tunnel boring machine, Martina was deployed to excavate the Sparvo tunnel in Italy. Weighing an impressive 4,500 tons and extending more than 400 feet, Martina was crucial to the Variante di Valico project, which aimed to enhance the A1 highway's infamous stretch across the Apennines. This path was well known for its steep slopes, sudden turns, and regular traffic jams. Martina finished its segment of the project in merely 2 years, establishing a record then for the quickest hard rock tunnel boring machine excavation. However, records are made to be broken. The Shanhe tunnel boring machine later demonstrated that similar tasks could be accomplished in just months, showcasing the rapid advancements in tunnel boring technology. Meanwhile, China continues to solidify its expertise in the field with groundbreaking projects that set new benchmarks for efficiency and innovation. Building on its reputation for engineering innovation, China made headlines last year with the launch of the world's largest single-shield hard rock tunnel boring machine, aptly named Caucasus. This impressive machine, measuring 49 feet in diameter, was utilized at an elevation of 6,000 feet to excavate a tunnel through the imposing Greater Caucasus mountain range. The Caucasus tunnel boring machine was put together in an unprecedented 3 months and given the responsibility of digging a tunnel for a significant highway project. Remarkably, it finished the task 30 days earlier than planned, which is an exceptional accomplishment in a field where setbacks frequently occur. boring through mountains presents significant difficulties because of the massive forces needed to slice through solid rock, which is a sharp difference from the relatively softer materials located under rivers or lakes. To tackle these obstacles, the Caucasus Tunnel boring machine was designed with a remarkable thrust capability of 22,600 tons. China has demonstrated its capacity to innovate and implement infrastructure projects at unmatched speeds, highlighting the strengths of contemporary engineering and the revolutionary possibilities of advanced machinery. The Jinan Huanggang Tunnel project not only addressed a vital urban issue, but also established a benchmark for efficiency and technological superiority in worldwide infrastructure advancement. And that's about it for this video. If you enjoyed learning more about the machines behind the mega project, be sure to hit the like and subscribe button for more videos like this one. Which of these tunnel boring machines impressed you the most? Let us know in the comments below.